Hello everyone. Today we'll do geography for class 7, right? Now we are going to do the same chapter, that is lesson number. This is class, one second. Class 7, lesson 3, tides, right? Tides, country. Tides, country. Okay? Now, here, last time in the last class we had done tides. Now, what is a tide? It is the rise and fall of the water level from, time to time. The rise of the water to a very high altitude and then coming down. After every, see here it was given after every 12 hours and 25 minutes. And that is due to the gravitational and centrifugal forces that interact between each other. That's the reason why the water level rises up and comes down after every 12 hours 25 minutes. Okay. Now here, to understand the difference between gravitational force and now the next question I should say, right? What is centrifugal and what is gravitational force? And what is the centrifugal force? In the last class I had explained and given a detail about it. Centrifugal is, like, since what do I say? Suppose if this is the ball, the world is round, the globe is a round ball, a huge round ball, right? That is the earth. Now, that being the case, we people are standing on top of that ball. We people are standing on top of that ball. Now, can anything stand on the ball or can anything be put on a ball? No, it always falls down. Now, why it falls down? Because it doesn't, it's a round thing and there is no flat surface that we can stand on. But yet, in spite of falling down, instead of falling out, we all could have fallen and we would have been flying in the galaxy or the universe or whatever you want to call it as. But it is not so. What it is, that we are still on top of the huge ball called as Earth. Now, why are we standing on that huge ball? Why are we able to do that? That is because of the gravitational pull. That is because of the gravitational pull. So, one we have is the centrifugal, okay, and the other one is the gravitational. Centrifugal force, we can say, and the other is the gravitational force. Got it? Now, what is centrifugal? Centrifugal is throwing out. It is the throwing out of any object. Throwing out of any object. Got it? And what is the gravitational? It is pulling of any object. So the earth has a huge gravitational force and such a massive force that even the centrifugal force is nothing compared to the gravitational force that the earth has. So instead of we falling out and swaying in the universe or something like that, we are still held on the grounds of that earth, round ball, because the gravitational pull is pulling us and making us stand on it. And when we are standing from our point of view, from the thing, everything appears to be flat till we reach that particular point. Okay, now suppose if I am in this classroom, for me this is a straight thing and a flat surface. So I walk down till that window. Now what happens? Till then it's fine because it is appeared. So I might take a left, a right, or continue, or I might just move back. But whatever it is, the earth's surface that it has, everything has a huge magnetic force inside that, or the gravitational force in it, that pulls us and makes us stand firm on the earth. So the same way, and I had told you to try the experiments that are given in the textbook. I hope you have all tried and found out the reasonable expression as to what happened. See, now why the centrifugal force is taking place? Because the earth is moving very fast on its axis. So now, suppose if it is moving so fast, if this is the earth, if my fingers, or if should I say the duster is the earth, and the chalk is over there, the way it is moving very fast, because it moves, isn't it? The earth is rotating very fast on its axis. So do you think that this chalk can even stand on it? No, it is bound to fall. It is bound to fall out of the huge round thing called as earth. Right? But at the same time, it is standing over there. Sorry. It is standing over there for the simple reason because of the magnetic pull or the gravitational pull of the earth. Understood? So that is centrifugal and gravitational force. Now here centrifugal means going, see here the geographical explanation is given on page number 10. That is centrifugal means going away from the center, as well as the gravitational is coming towards the center. Centrifugal is going away and gravitational is coming, right? Now here they have given the following factors are responsible for the occurrence of tides. So because of that, gravitational pull and centrifugal force both interacting between each other causes the tide. Okay, after every 12 hours and 25 minutes. Now what are the factors responsible for that gravitational for the occurrence of tide? The gravitational pull of the moon and the sun, as well as that of the earth. Then we have revolution of the earth around the sun and the indirect revolution of the moon around the sun. Centrifugal force generated due to the rotation of the earth. So these are the various factors responsible for the cause of tides. This is what we have done in the last class. When there is a high tide at 0 degree meridian, the 180 degree meridian also experiences high tide. The meridians that are at right angles to those having high tide will experience low tide at the same time. If it is high tide at 0 degree and 180 degree meridians, then at which meridians will low tide occur, that you have to find out. Okay. Now we'll continue with the chapter by the topic types of tide. Now we have learned as to what a tide is, why it occurs, and the factors responsible for the tides. Now we are going to do types of tides. As the timing of the tide varies every day, the range of a tide also keeps on changing. Okay, generally the highest high tide occurs on full moon and new moon days, whereas on the days of the first and the third quarter, the high tide is at its minimum. Spring tides and neap tides are the two types of tides. Now we know that tide occurs definitely, because if it is occurring after every 12 hours 25 minutes, that means it is occurring every day. But so when is it highest? It occurs, the highest level of the high tide is on full moon day and the new moon day. And on the other days, we have done that what is a full moon day and a full moon new moon day. So on those days, that first, that is the beginning of it, and the third part of it, the tide is very low. But when it is full moon and full new moon, then the high tide is very high. So the two types, now we have two types of tides for that, that is spring tides and the neap tide. Okay, now what is a spring tide? A new moon tide, please underline this when I'm reading. The definition is very clear in the textbook, so you don't even have to refer to any digest or anything, because every answer is given very clearly in the textbook. So if you read the textbook and the question answers, you get all the answers in the textbook itself. So on new moon and full moon days, the gravitational pull of the sun and the moon act in the same direction. So the gravitational pull of the sun as well as the moon, they pull in the same direction. Due to this, total pull increases. So definitely, when you are putting, suppose if I am pulling something and then in this direction, and if there is another person, like we play tug of war. So that rope, one is pulling this side and the other one is pulling the other side. But if the other side also comes and joins me and we pull the rope together on one particular side, so whatever force that I am applying to the rope becomes double, or it becomes even more heavier, easier for us to pull that the rope over this side. So it's the same way over here also, that on the new moon day and full moon days, the gravitational pull of the sun and the moon act in the same direction. Due to this, the total pull increases. Hence, the tide on these days is much higher than average high tide. This is known as spring tide. This is known as spring tide. As the bulge at the high tide is greater, the water at low tide recedes much more. The water level during spring tide is higher than the average high tides and lower than the average low. Now here they have given the spring tide. They have shown what a spring tide is all about. See, in this diagram, they have shown the sun is somewhere on this side. Okay. And they have shown the moon on this side and earth on this side. So, in the last class, I have said they are all in the oval shape. They never rotate in a circular thing, they rotate it in the oval shape, or that, right? So they are never in the same thing. So when here they have shown the level also. If you see in the figure, I don't know if I can this thing. Okay. So here they have shown the level of high tide and the low tide also. Here they have marked it as okay. So one side they have marked it as dark, then light, then dark, then light, dark, light, dark, light and dark. So that way. And if this is the moon, this is the moon, this is the sun, and this is the earth. Okay? And here we have the North Pole. Here we have the North Pole. Now the pull of now what is over here? The gravitational pull of the sun and the moon are in the same direction. That is when we have the tides. That is when we have the tide. It's either high tide or the low tide. Okay? High tide and low tide. Right? So if you see the diagram over there, it is very clearly shown as to how the tide, that is the spring tide. This is how the spring tide. This is about the spring tide. Okay. So this is one type of the tide. There are two types of tide. One is the spring tide. The other one is the neap tide. Okay. Now, what is a neap tide? That is the next one. While revolving around the earth, the moon makes a right angle with respect to the earth and the sun twice a month. This position occurs on the first and the third quarter of each month. And every month, so with the moon is, we know that the earth is revolving around the sun and the moon is revolving around the earth. And because it is revolving around the earth, that means whenever the earth is moving around the sun, indirectly the moon is also taking a revolution around the sun. But here, while revolving, for the neap tide to happen, while revolving around the earth, the moon makes a right angle. So a time comes when the moon is making a right angle, and which occurs basically twice in a month. That is also during the first and the third quarter of each month. That means first quarter is that the moon is going to be the new moon, and the third quarter is going to be the exit of the full moon. So in both the cases, when the moon is going to become a full moon, in the beginning you just see a new moon kind of a thing, that is because of the revolution around the earth. So we'll find that it is taking that way, and the moon taking or making a right angle. Okay. On both these days, the forces of both the sun and the moon operate at right angles on the earth. At the places where the sun causes high tide, the gravitational pull of the moon, which is at right angle, also acts on the sea water. Due to such conditions, the water level rise is less than usual at the time of high tide. Similarly, fall in water level is less than usual at the time of low tide. So this is because the attraction of the sun and the moon are not complementary but at right angles to each other. Such tides are called neap tides. Neap tides are a little lower than the average high tide and a little higher than the average low tide. Now what is a neap tide? Neap tide happens during almost like, during it occurs twice in a month, that is, the moon making a right angle towards the earth, that is twice a month on the first quarter and the third quarter. And at places where it causes the right angle, it also acts on the gravitational pull of the sea water, isn't it? So due to such condition, water level either rises so the water rising the level of rising water is low than the usual high tide. Similarly, fall in water level is also less than the usual at the time of low tide. That means it is almost peacefully flowing. Okay, this is because the attraction of the sun and the moon are not complementary. That means they are not in the straight line, they are at the right angle. So such tides are called as neap tide. Neap tides are a little lower than the average high tides and a little higher than the average low tides. Now, intertidal range. So what is the intertidal range? The difference in the water level of the high tide and the low tide is called tidal range. In open seas, this range is about 30 centimeters. However, towards the coastal area, it goes on increasing along the coast of peninsular India. The range is around 100 to 150 centimeters for most of the part. The highest paid, the highest tidal range in the world is observed at the Bay of Fundy along the Atlantic coast of North America. Here the tidal range is about 1600 centimeters. In India, the highest tidal range is in the Gulf of Khambhat. It is about 1100 centimeters. Now, what is intertidal range? The difference between the water levels of high tide and low tide is called tidal range. You know the difference when we measure the, for everything when we measure, then we come to know. Here in page, see, this was about the spring tide, and in the figure there is another one that is about the neap tide. Okay. Now here we usually have the high tide, and here we usually have the low tide. But what is intertidal? What is a tidal range? Tidal range is the difference between the water level during the high tide and the low tide. Okay, so please underline that. And towards the coastal area, it goes on increasing. So that is like when coastal areas is near the seashore. I mean, like the land near the water. Along the coast of peninsular India, the range is about almost around 100 to 150 centimeter for most of the part. The highest tidal range in the world is observed at the Bay of Fundy along the Atlantic coast of North America. Here the tidal range is about 1600 centimeters. In India, the highest tidal range is in the Gulf of Khambhat. It is about 1100 centimeters. Okay, this is what, yeah. So now types of, we know what a tide is. A tide is the process occurring because of the gravitational and the centrifugal forces playing on Earth, and it happens only after every 12 hours 25 minutes. Then we have the factors responsible for the tide, and then we have the types of tide. One is the spring tide and the other one is the neap tide. Now we are going to do the effects of a tide. Now, what happens when the tide occurs? What happens when the tide occurs? With the high tide, fish move into the creeks, and this helps fishing activity. Now, what is a creek? Any idea? Creek is a place, like we have small, like we won't call it as a mountain as such, but creek is a small passage. The land is there and the water is there. So whatever the landform that we find, it's a stream. We could find, it's a stream between those. So whatever the stream that is flowing from the sea water, when the fishes go there, that is called as the So high tide is the time when fishing activity is very good, because the water level is rising high. It brings all the fishes with it and throws them to one side. The tides clear the waste, and hence the coast becomes clean. So the level of water. So the water, when it is rising high, it takes whatever dirt, whatever thing that is there in the water, including the human beings. It just throws them out that way. So that means in a way it is kind of cleaning. Of course, we might get hurt in the process, and we might also get fishes, various kinds of fishes for the fishing activity. Like many people eat fish and everything, so that's a delicious delicacy that we have. And the other thing is, it clears and cleans the water. Okay, ports do not get filled with sediment. What is a sediment? I don't know if you have learned that word. Sediment is, depositing of sands, or it's not only about sand, it is depositing any kind of things on a side. So that is called as sediment. Whatever it throws, the water comes, whatever thing comes, or if you stand on a, beach, like the water level is coming, then it gets on whatever things is there, and it touches your feet over there down, isn't it? That is seashells also you get, Then you get various kinds of insects also, that is crabs and all moving creepy crawly things over there. And then you have seahorses over there, then you have fishes and everything. So all that thing you find it. So the water has thrown whatever it brings with it, it throws on the side, and that is called as, dumping it on one side. So in a way, it is trying to clean the dirt of the sea that it has. Understood? Now I guess we are going to end up over here with this chapter. We'll continue it in the next class of geography. Okay.